In this video for Positive Maths, we're going to look at an exam question involving complex numbers. So this is from the 2012 paper. It's paper 1, question 4, part B. Before we start this question, I'm going to outline some of the key things that we need to know. If we take z as a plus bi, then for part 1 we need the modulus of z. So this is equal to the square root of a squared plus b squared. And for part 2, we need the conjugate of z. So that's equal to a minus bi, where we change the sign of the imaginary part of the number. So part 1 asks us to find the modulus of z when z is equal to 1 plus I. So therefore the modulus is going to be equal to 1 squared plus 1 squared, which is equal to the square root of 2. So then for part 2, they ask us to show that z squared plus the conjugate of z squared is equal to 0. So first we're going to identify what the conjugate of z is. If z is equal to 1 plus I, then the conjugate of z is going to be equal to 1 minus I. So z squared is going to be 1 plus I squared. And then the conjugate is going to be 1 minus I squared. We have to show that this is equal to 0. So if we square the first brackets, we're going to get 1 squared plus 2i plus I squared. So we square the first term, twice the product of the two terms, and square the last term. Otherwise, you can write out the two brackets and multiply them out. You'll still get the same answer. Okay, for our second bracket then, square the first term, so that's 1 squared. Twice the product of the two terms is minus 2i. Square the last, we get plus I squared. We want to notice another key piece of information. I squared is equal to minus 1. So whenever we have I squared, we always change it to minus 1. So now we're going to have 1 squared is equal to 1 plus 2i. Instead of I squared, we're going to fill in minus 1. Plus 1 minus 2i minus 1 is equal to 0. So if we notice 1 minus 1 is going to give us 0, plus 1 minus 1 again is going to give us 0, and plus 2i minus 2i is going to give us 0. So therefore, when we simplify it, it is equal to 0. So for part 3, they want us to verify that 1 plus 5i over 3 plus 2i is equal to z. What we want to remember then is z is equal to 1 plus I. So we have 1 plus 5i divided by 3 plus 2i. What we want to remember here, that in order to divide two complex numbers, we multiply the numerator and the denominator by the conjugate of the complex number on the bottom. So the conjugate of 3 plus 2i is 3 minus 2i. So when we multiply that out, we're going to get 1 plus 5i multiplied by 3 minus 2i on the top. And on the bottom, we're going to get 3 plus 2i multiplied by 3 minus 2i. So 1 multiplied by 3 minus 2i is going to give us 3 minus 2i. Plus 5i multiplied by 3 minus 2i is going to get us plus 15i minus 10i squared. On the bottom, we're going to get 3 multiplied by 3 minus 2i is going to get us 9 minus 6i. Minus 2i multiplied by 3 minus 2i is going to get us plus 6i minus 4i squared. So again, we'll just continue to simplify. What we want to note is that we have I squared, so we need to change that to minus 1. So we're going to get 3 minus 2i plus 15i is going to give us plus 13i. And now we have minus 10 multiplied by minus 1. So 9 minus 6i plus 6i, so they're just going to cancel. So we have 9 minus 4 multiplied by minus 1. So this is going to give us 3 plus 10 now is going to give us 13 plus 13i. And on the bottom, it's going to be 9 plus 4, which will give us 13, which does simplify to be 1 plus 1i. So we have shown that 1 plus 5i over 3 plus 2i will simplify to be 1 plus 1i. For more information, visit PositiveMaths.ie, email us at info@PositiveMaths.ie, and find us on Facebook and Twitter. Thanks for watching.